Okay, year 11, I'm just going to go over exponential functions and drawing their sketches of these curves, and then also I'm going to do a little bit on Euler's number. So we did these in class. I particularly wanted to look at questions 3 and 4. So if I have a look at question 3, and I want to find these equations. So question 3, f of x equals 2 to the x, and g of x equals 3x plus 4. I hope that's what it is. I've sort of got a glitch there, but I'm pretty sure that's what it is. Now, if I, for the first one, I have to find f of g of x, which means I'm going to put this where the x is. So that equals 2 to the 3x plus 4. And I should write that in parentheses so you know that it's all up there. For the second one, when I'm doing g of f of x, I'm just going to do the opposite. I'm going to put this time, I'm going to put that in where the x is. So it's 3 times 2 to the x plus 4. And you don't multiply that 3 and that 2 because that 2 is not, you can't multiply it and get 6 to the x. It just stays as 3 times 2 to the x plus 4. Now in question 4, and this is important because we've got to learn to flip these graphs. First of all, I've got this function which is f of x, which is 4 times 3 to the x plus 1. Now, we're going to look at Desmos in a minute to see how this affects this curve. But I'm just going to go over here and I'm going to get a shapes. I'm going to get the big x-axis, x and y-axis, number plane. Now, normally, we go, that 4 just makes it steeper and that moves it up 1. All right? So let's have a look. First of all, our standard one goes through like that, and that's a 0.1, and we've got an asymptote there. But we're moving it all up 1. So get me back here. Yeah, that's what I want. I want to get rid of all those little dots I just did. So, and I'll get rid of that now. So my asymptote is going to move up 1, and the whole curve is going to move up 1. But it's even more interesting than that because the intercept is not just going to be 1. That 4 does more than make it steeper. So, well, it makes it steeper, but then it also affects the intercept. So the first thing I want you to make sure you can do is on your calculator, is you can put it in and try some values. So we've got 4 times 3 to the power, put my 3 in, to the power. Now, let's just start. Let's find the intercept. 0 plus 1, 5. So it's going through 5. So it's moved up, but the intercept is going to be at 5. Now, I know it's not going to, there's going to be an asymptote down the bottom here, but I wonder where that is. I know that this shape is going to look something like that, but you know, how far down does it go? Where's the asymptote? Well, one of the ways you can do that is you want to find out what happens when the number in here goes way down here, say negative 100. way down there. So I'm going to try and do that on my calculator. So I just use the back arrow and I make that negative 100. I'll make it negative 10. And it's 1.00006. Let's make it negative 100. And it says it's 1. Now, it doesn't actually equal 1. It gets very, very, very close. But you can therefore work out where your asymptote is. So here, my asymptote, and I'll do it in green, is there at 1. And this curve, therefore, looks like that. And I'm going to move that there. Oh, I just want to get that. I'm just going to leave it in there because I don't think I'm going to be able to. But here's the value of 5. Maybe I can get in there if I go really zoom it in. There it is. It's gone. Right. So that's where it is. Now, what have I got to do with this curve? Well, these two things, flip it. Now, one's going to flip it in the y-axis and one's going to flip it in the x-axis. And if you're ever unsure, you can try some values. So the first one here, that's just going to get all the negative x values and swap them with all the y. So that one is going to go this way. So that's y equals f of x. And this, and I should put arrows on it, is y equals f of negative x. Put my arrows on this one. Now, if I do negative f of x, it's going to flip it over this line. So I'm going to choose another colour and I'm going to do it in blue. So it's going to come all the way down here and it's just going to go up there. There's my -1. And I'm flipping the red curve so it looks like that. So we get that 5 in the right spot. There. And that's -5. Now, if I flip it twice, and that's what this does. So flip it twice. I can either now flip this green one down or flip that blue one to the right and left. And I think I'm just going to flip that blue one because it's nice and easy, and I'll make it purple. So it's going to go like that. Now, you can check by putting values in and subbing them in, but the other way you can check is by going to Desmos. And Desmos is so good. So we'll type in Desmos. And if we define this as f of x rather than going y equals, and what was it? It was 4 times 3 to the x plus 1. And you can see it there. Now we've done that, let's go y equals, well, I don't need a capital Y equals f of negative x. And there it is. There's one we did before. Okay, well, let's go y equals negative f of x. And there's the one we did before. So see how it flips? And then one more, let's do y equals negative f of negative x. There you get all those curves that we just did. So check by subbing values in by using your calculator, but also check by using Desmos. It's a great tool. Okay, so questions 3 and 4 from exercise 10.01.